Operation, or if you prefer, running trains is what the prototype and model railroad have in common. Both depend on good track work for good performance. Derailments are not just part of the hobby, no matter what your scale. Laurel Joyner is going to help you solve your track work problems in Building Reliable Model Railroad Track, presented by Model Railroader Magazine. Laurel's beautiful O-scale Great Southern is testimony to 30 years of model railroading experience, and that includes lots of track laying over the years.
This is pretty good iron they laid here. Can you say the same about the last track you laid? If you're a bit unsure, why don't you let me show you how I go about it? Everything I'm going to show you I had to learn by trial and error. So that you don't have to reinvent the wheel, or in this case track standards, why don't you join the National Model Railroad Association, get their data book, and one or two of their track gauges for your scale. Follow the standards and you'll have very few problems with your track. Oh, I know track work can seem very complicated, but if you follow a few simple rules, all the complications will either disappear or become completely manageable. Real railroads have track standards, so should yours. Don't let all this track work terrify you so much that you take up decoupage. I'm going to make this as painless as possible and show you the track is not drudgery. It can actually be fun and satisfying.
Hi, Laurel.
Hi, Alan.
I know you want to discuss track work, but how about spending a little time first with the layout foundation?
Sure, Alan. Good track work's impossible without good solid bench work, sub-road bed, and road bed. So let's take a look at some of the most common types of bench work. One of the best known types is L-girder. Lynn Westcott designed it for strength and lightness. It gives you the ability to move the supporting joist after the railroad is in place. As you can see, it gets its name from the L-shaped flange that's screwed or glued at right angles to the web. Another method is perhaps the most widely used by beginners. It's the tabletop where a 4x8 sheet of plywood or an old 5x9 ping pong table becomes the surface of the layout. It's heavy, weak, and expensive. It's also deadly for scenery because you can't put anything below the track level. It's great for ping pong, but don't build your pike on it unless you have no other option. The modular layout is gaining popularity because it's portable. It can be a simple combination of L-girder and tabletop. It combines the best features of the two. It's lightweight, simple, and buildable by the beginner. The open grid method is exactly what the name implies. It's an open grid like this. It uses a lot of lumber and requires very accurate cutting of the cross members. It lacks vertical strength. The system I use is my own design, but it's for the person who doesn't anticipate moving. It's very heavy, but that's a plus for the permanent layout. It's also very solid. It's an adaptation of a house construction method called Western framing. In fact, it's stronger than the house that holds the layout. You can dance on it if that sort of thing appeals to you. It is expensive, but doesn't require very accurate cutting and fitting. That's a quick summary of a subject that's just about as complicated as track work. But you plunk down your nickels and dimes to talk about track work, so let's move on up to the subject of sub-road bed and road bed.
There are several types of sub-road bed. Which do you recommend?
I like the flat plywood sub-road bed. It should be 5/8 inches or 3/4 inches thick with exterior glue, grade BC or better. You cut it with a saber saw to follow your track plan.
Well, what's the best type of road bed?
I prefer two kinds, Homosote with white pine boards and Homosote by itself. Homosote is a brand of paperboard that's just perfect for holding spikes. When it's sandwiched between a good grade of plywood and white pine on top, it's darn near indestructible. Homosote can be hard to find, but it's worth the effort. Don't under any circumstances buy black insulating board, Upson board, or acoustical ceiling tile. They don't hold spikes. In your yard, you lay track directly on the Homosote. Real yards are usually flat with no buildup of ballast. Laying track directly on Homosote is a joy. Out on the main line, elevate the track with this white pine road bed. TrueScale makes it for HO. I urge you to avoid cork and rubber road bed. They don't hold spikes, and they don't muffle sound any better than Homosote. While we're talking about road bed, let's touch on track centers and radii. As you know, the larger your equipment, the broader your curve should be. Straight tracks can be closer together than curved tracks. That's because the equipment overhang is less on straight track. Since model railroading is the art of saving space, you always want your straight tracks as close together as possible. Now, if your yard tracks are spaced 13 feet apart, center to center, and your curved tracks are 20 feet center to center, you have a problem when they meet. The answer is a transition spiral or easement. We'll cover that later, but for now, let's get your track plan converted into actual pieces of sub-road bed. This homemade trammel is really just a wood stick with a hole at this end for a pivot nail and several holes along the other end. These holes are for the different radii you will be using. The trammel can mark the center line for, let's say, a 22-inch radius. Keeping the nail in one spot, then mark the center line of a 22-inch radius. Now, move the pencil to 21 and mark a 21-inch radius. Move the pencil to 23 and mark a 23-inch radius. That's pretty easy, isn't it, huh? Then you just cut out this template along the outer lines and use it as a pattern for your plywood as often as you want. Lay the template directly on the benchwork. Reposition it until the track flows smoothly. Then mark its position on the benchwork. Then use the templates to cut your sub-road bed out of plywood with a saber saw. It's a good idea to make templates for all of the curves you will be using. Now you do the same thing for your homosote. Make it 2 inches wide. This gives you a little ledge to attach your scenery.
In O-scale, the sub-road bed and road bed would be about twice as large, and for N-scale, they would be about half as large.
Yes, and another difference applies to hand-laid track. There I prefer to mark the inner and outer edges of the ties on the white pine road bed because then I'm able to align them when I lay them. So now the sub-road bed and road bed are down and you're anxious to start running trains. Commercial flex track is a great way to go. Flex track comes with several rail sizes in almost every scale and gauge. The most common for HO are codes 70 and 100. All the word code means is the number of thousandths of an inch in height from the base of the rail to the top of the rail. Code 70 means it's 70 thousandths of an inch high. You don't have to stick with one size. Use code 100 or even code 83 on your main line and code 70 for branch lines and yards. You could even use code 55 for industrial tracks in HO. To make the transition from one size rail to another, you slip a rail joiner on the larger size. Then flatten the rail joiner so it becomes kind of a ledge. Then solder the smaller rail on it, and now you clean up with a file.
Laurel, what's the difference between brass and nickel-silver track? Is silver better?
The snap track found in train sets is brass or steel. You want to stay away from it because brass oxide doesn't conduct electricity very well, and steel rusts. Nickel-silver doesn't really have any silver. It's just nickel-bearing brass. It costs a little more than brass track, but the oxidation problems are much less. That means your trains will run a whole lot better. Stay away from steel rail. It's hard to solder and it's a very poor conductor of electricity. But now let's get down to the nitty-gritty of laying flex track. Listen up because there's just a few tools that you've got to have to successfully lay flex track. You need needle nose pliers, needle files, soldering iron and rosin flux solder, a 24-inch or longer metal straight edge, a motor tool with a cutoff disc, a razor saw, flush cutting rail nippers, rail joiners, a small tack hammer, a hobby knife with a number 11 blade, a pin vise with about a number 60 bit, spikes, small brads, and of course the most useful item. Next, decide if you want to use spikes or track nails on your flex track. Track nails go down the center in the holes left by the manufacturer or drilled with your pin vise. This method fixes the track firmly, but doesn't really help at the ends of the section where all the lateral springing occurs. For that, you'll need plenty of spikes. Of course, you can use spikes by the rails without the track nails. That's a pretty good system. My main objection to track nails is that if they're driven in too far, they cause the rail to V up. As you might notice, this changes the gauge just slightly.
Can you use both spikes and nails?
It takes a bit more time, but the track is down solid, and temperature changes won't make much difference anymore. Many modelers make a practice of using as few fasteners as possible and letting the bonded ballast hold the track. If it works for them, fine, but I don't recommend it. You really can't be sure if the glue will hold the track in the proper horizontal and vertical alignment. There's an old rule about gluing and soldering that I try to follow. Have firm mechanical connection between the two and never depend on solder or glue. Let's assume you use both nails and spikes until you become more experienced. When you bend flex track, one rail becomes longer than the other. Even the two up again with rail nippers. Keep the flat side of the nippers facing the piece of rail you want to keep. Rail nippers or flush cutting pliers are made by several companies and are really essential for track laying. Keep your cuts square. Rail joints can cause derailments if done improperly. You can also cut the rail with a razor saw, or you can use a motor tool with a cutoff disc. After you've cut the rail, you'll have to remove any ties that are in the way of the rail joiners. Save these because you'll need them later.
Laurel, if the end of the rail is smooth, is that all you need to do?
No, use a needle file and clean all the surfaces. First file the top, the sides of the head, the web, and the top and bottom of the flange. A rail joiner should slip on rather easily if the whole rail end is square. Here's a hint on rail joiners. Take a small screwdriver and pry open the ends a bit. This will help the rail fit much better. Slide the new rail up against the track you've already laid and see if they fit. If they do, then prepare to lightly spike them in position, like so, and once on the other side, like so. Now you're ready to solder the rail joint. A warning here, don't wait until all your track is laid to solder the joints. If you do, the track can creep and open up. An error will build up that will be intolerable. As we solder, let's talk about soldering practices in general. You should know the 3 rules of soldering: cleanliness of the materials in the iron, adequate heat with a tin tip, and cleanliness of the materials in the iron. Get the picture? If the materials aren't clean, you're wasting your time. All tinning means is coating the tip of the iron with solder and then wiping it off on a damp sponge. This helps transfer the heat from the iron to the work. Repeat this procedure every so often. You need a fairly large iron in the 47 to 80 watt range with a flat chisel tip about a 1/4 inch across when working in HO or larger scales. Don't use a soldering gun if you can avoid it. The pre-tinned or plated iron tips are the best. Use only rosin core solder. Never use acid core solder anywhere on the layout. Use a small wire solder, as small as you can get. A bulky solder is too large for fine work and requires far more cleanup time. Use a 6040 or 6337 solder. It's available at electronic supply stores and Radio Shacks. When soldering flex track, you have to be careful to not melt the plastic ties. Now, they're going to deform a little bit, but you don't want to melt them. That's why you need a fairly large iron. It heats the material quickly. Touch the iron to the inside of the rail and apply solder from the outside of the rail. This will keep the solder from forming a blob on the inside running surface of the rail. You just have to slowly file it away to prevent derailments. After the joints have cooled, look at them. If they're silvery and shiny, all's well. If they're dull, the color of lead, you have what's called a cold joint. That means not enough heat was applied or the parts were moved after the solder started to cool. Reheat the joint without adding more solder and allow it to cool without movement. Now file the joints so that all excess solder is removed and there's no visual evidence of a break in the rail. It's necessary to file both the sides of the rail, inside and out, as well as the tops. Next, take your hobby knife and thin those leftover ties so that they slip under the rails. Put the ties in the areas that don't have them, under the rail joiners. Glue them down with ACC and then drill some holes for spikes. If you spike the ties, there will be no worry about a kink appearing. Now, Alan, here are some tips on flex track in general. For very straight track, use a 36-inch metal straight edge and drill 2 holes in it, one at each end. Push the straight edge up against the web of one rail and nail it lightly in place. Then, while firmly pushing the track against the straight edge, spike or nail the track in place. If you have someone to help, it sure is easier. The straight edge gives you very straight track. Don't try using a stretch string or chalk line. They don't work. I know, I've tried them. For smooth curves with flex track, mark the center of the track. On your Homosote roadbed, mark a center line. There's no need to do that with milled white pine roadbed. I've seen people use all kinds of wires, trammels, and radius gauges, but the human eye is still one of the best devices for laying curved track. Bend the track and get it to retain the bend even before you think about nailing it down. I solder two pieces together before I spike down the track completely. This eliminates any kinks at the rail joints. Now I've soldered the joint and spiked down the first piece, leaving a few inches loose at the end. And now I flex it into its approximate final shape and mark the rail ends so they're even. And nip the rail at the marks. Remove the ties that are in the way and save them. You'll need them later. The second piece is spiked to within 10 inches or so of the end. Then you just repeat the process with the third piece. Go back to the straight section and look at the track from a low angle so you see the track much as the engineer of a train would see it. Look for kinks and bumps. Also be sure the rail doesn't lean to one side or the other. If everything is smooth, then it's time to start putting the ties back under the rail joints.
Laurel, why did you start at only one side of the curve? Why not work both sides toward the middle?
That's a no-no. Only work from one straight section into the curve, then continue around the curve to the next straight section. If you run into a situation where you have to fill a gap between two previously laid pieces of track, measure carefully, cut the rails cleanly, file the ends, and test fit. Put rail joiners on all four ends. Use your needle nose pliers to slide the rail joiners onto the connecting rail and solder as usual. This is a good place to mention super elevation. The outer rail of curved track is higher than the inner rail. It's used by real railroads to offset the centrifugal force of a train going through a curve. It's not needed on a model, and unless you're an experienced track layer, I really suggest you steer clear of it. With our lightweight cars, I've seen super elevation actually cause derailments. If you decide to use it, you must consider 2 points. First, the outer rail should be a scale 4 to 6 inches higher than the inner rail. Second, you must gradually increase the height of the outer rail. Start the grade on the straight or tangent track so that when the curve is reached, the height will be right.
Well, if you have super elevation, do you have to have a transition spiral?
Yes, you should. You see what I mean about super elevation being only for the experienced track layer? If you do super elevate, use wood shims to raise the rail. Under no circumstances should you use cardboard or paper. Since you brought up that dirty phrase, transition spiral, we should talk about it now. Some of you might wonder what I'm babbling about, and others may be wishing the whole thing never came up. Really, though, transition spirals are not that bad. A transition spiral is a non-circular curve connecting a tangent track with a circular curve. It's used to improve the appearance of the train as it goes from the tangent into the curve. There are all kinds of mathematical horrors associated with transition spirals, but I'm going to show you a simple shortcut, the bent stick. Let's assume you have a curve of a given radius. I'm using 22 inches here. You want straight track about here. Take a smooth, supple stick and bend it to the 22-inch radius and let it go gradually straight. Mark it with a pencil and you have a reasonable approximation of a transition spiral. Lay out your curves first and then use the bent stick to determine where the straights go. This simple extra step will assure you a smoother operation. Weathering is a good way to make flex track look hand-laid. The secret is an inexpensive airbrush with a propellant can so that you're not tied down with an air hose. Spray the whole shooting match, including the rail, with a flat black gray mix of model railroad paint. You should always paint the track before ballasting. Let this dry a couple of hours. Then spray boxcar red, heavily diluted with dirty thinner. Hit it from a low angle so the sides of the rail get most of the paint. If you miss a few places, no sweat. You won't have to clean the rail tops until after ballasting unless you just have to run a train. Of course, I've always been able to hold off because I have a large share of moral courage that comes from leading a pure, clean life. With that note, I'd better change the subject. Okay, put down the airbrush and use a 1/8 inch or 1/4 inch brush to highlight the ties with diluted brown and rail brown. Really heavily thin, please. And a few streaks of black laid on while the brown is wet. It should all run together and be a smeared brown gray, black gray. And the color should be muted and subtle. You don't want it to look like a painter's drop cloth now. If the colors get too intense, you can always come back and repaint it. Remember, use enough spikes to keep humidity and temperature changes from causing this. Use a soldering iron that's not too large, or you may start a new hobby, remelting plastic ties. Transition curves can be intimidating, but the wood stick is a close approximation. Now let's talk about one of my favorite subjects, hand-laid track. If you're a beginner, listen up for a few minutes. Hand-laid track isn't as hard as it used to be because there's a few new ways to go about it. Well, it's not that easy, but it may be easier than you think. You've probably heard a few old-timers say that flex track is so good now that hand-laid isn't worth the effort. Well, that's a matter of opinion. For my money, hand-laid track with wood ties is still the best-looking track. If you don't feel comfortable hand-laying now, use flex track on your current layout, but save the following ideas for your next endeavor. Enough of this. Let's get down to brass tacks. I mean nickel-silver tacks. Everything we've said up to now about bench work, sub-road bed, and weathering holds true for hand-laid track too. But now you've got to talk about ties as a separate entity, and I suggest you buy them unstained. I have a pet theory that model ties look better slightly closer together than real ties. The idea is that the eye naturally sees a closely spaced tie as being part of a longer track. You could settle on two spacings, one for the main and the other for the yards. So you need one or more jigs. The jig is simply an easy method of putting down a lot of ties at once. Here's one of the jigs I built. It's about 3 feet long with a thin strip of wood along this edge as a guide for the ties. These blocks of wood are spaced so that ties fit between them, like this. So and so. You just load the jig with stained ties, tape them down, make it stick, remove them, and glue them to the roadbed. Before we do that, though, let me show you how to stain the ties. Only new ties have a uniform color. The rest vary from black to silver gray. So divide your unstained ties into 4 piles. Mix up 4 batches of artist oil colors with lots of paint thinner. Use 2 intensities of black, diluted burnt umber, and diluted raw umber. You'll probably want about 1/4 of each stain to start. Experiment with varying amounts of thinner until you get a good shade. Then you can always make larger amounts if you keep a record of the recipe. Put a pile of ties in each of the 4 colors. Take them out and allow them to dry on newspaper. Be careful with this mixture. It's toxic and flammable. You probably should do this outside. After the ties have dried for about a day, we're ready to start laying them. Put a strip of masking tape over the ties. Use 1/2 inch tape for S and O scale and 1/4 inch tape for HO and N scale. Then just simply lever the ties out of the jig. Mix up a batch of 3 parts of white glue, 1 part water, and a drop of dishwashing detergent. Apply this to the roadbed with a disposable 1-inch brush. Now press the tie strip into the glue and align them carefully so you have a smooth track line. You can make a jig for your turnouts also. You don't need left and right hand versions, you just flip the ties. Let the ties dry for a day or two, then pull off the masking tape. Now look for bumps or sags.
Do you just feel the ties with your hand?
That might work for big bumps, but a metal straight edge is foolproof. Put the straight edge on the ties and shine a flashlight behind. Where there's light, there's trouble. If you have a high spot, just sand it down with number 300 grit paper wrapped around a 2x4. If you find a low spot, the solution is a bit more difficult. Mark where the low spot starts and stops. Then take full-strength white glue and coat each low tie. Put a new tie on top of each. Let this dry for 2 days. Then you sand it down just like you would a high spot. While you're sanding, check constantly with the straight edge and flashlight so that you don't sand too much. Now restain the ties you sanded and you have a lovely surface ready for rail. Look at your rail. It probably has a residue of oil on it. Wipe it down with a solvent-soaked rag. Dispose of the rag carefully and let the rail dry. Now is the best time to color the rail. Go outside and do what I showed you with the Flex Track. Here you might try something different. Say a 50-50 mix of boxcar red and roof brown. Let it dry and then mist it with a highly diluted grimy black. Don't cover up the first color. Let it dry a day or so on some kind of support so it doesn't kink. You'll have to clean the paint off the rail any place you solder, but it's a lot easier to do that than paint the rail realistically after it's spiked down. Solder 2 pieces with a rail joiner to make a section 6 feet long or so. File the joint clean on all surfaces. Make several of these sections while you're at it. It's easy to lay a long piece of rail smoothly, especially around curves. Don't make sections longer than 6 feet or so, because they'll bend under their own weight when you lift them. Track is a model just like locomotives and cars and deserves to be weathered. Let's spike some of those rails in place now. The Katy Spiker has made life easier for us track layers. It can be adapted for all scales and rail size. You can only buy it directly from Katy Metal Products, the coupler people, and it's fairly expensive. Fortunately, some hobby shops will rent it out. If you value your time, the Katy Spiker is a lifesaver. You use it like a staple gun. It's so easy, you'll automatically use more staples, and that's all to the good. Some folks report that if they press too hard, the rails get kinked. There's a tension adjuster on the top that determines the trip hammer force. Ease off on this if the rail is getting marked or kinked. For now, I'll assume you're using a Katy Spiker, but we'll cover hand spiking later. Here are the tools you'll need: a Katy Spiker or spikes and needle nose pliers, a small hammer, a small screwdriver, and a little patience. Oh, wait a minute, don't forget the rail. Let me show you how to lay very straight track. I developed this gizmo years ago and it's helped me enormously. It's the straight edge I showed you earlier. Now for HO and N scale, cut a 1/2 inch semicircular notch in the side about every 3 inches. For O, S, and G scales, cut the notch every 5 inches or so. Use a rat tail file or a motor tool to cut these notches. Precision isn't really important here. Now let me illustrate the use of this dude. Mark your ties every few inches, like this, where the rail is to go. Pull the straightener up against these marks and line it up. Nail it down. Now it's similar to the gadget I use for straightening flex, isn't it? Except here the rail is just now going into place. Lay it up tight and push up tight against the straightener. Hold it in one hand and staple in the notch with the other. Move to the next notch and continue all of the notches until the first rail is spiked. Then remove the straightener and spike all the ties you want. Now you can gauge the second rail from the first.
That looked like fun, but I bet curves are really hard.
They're a little tricky, Alan, but still not hard. There are several ways to do it. One way is with a commercial template. This little doodad goes between the rails and gauges the track while it governs the radius. The other way is with the trammel. Remember when we laid out the roadbed, we marked the center of the curve. Now we can use those marks to help lay smooth curves with the trammel. Attach a 3-point track gauge to the end of the stick with a screw. The single leg should face the center of the curve. You can use the same trammel for all your curves simply by moving the gauge. If you use transition curves, set the trammel to where the circular curve meets the transition curve. Put the gauge on the loose rail and nail in the pivot nail. Simply swing the trammel and follow closely with the spiker. Once the first rail is laid, you simply gauge off it to lay the second rail. If you develop a little dexterity, you can lay both rails at one pass, but practice first. Perhaps the easiest way to lay curves is by eye, although it takes some practice. You don't want a rail joint at a crucial transition. Decide where the first rail falls on the ties. This is a variable since tie lengths are a personal choice. Anyway, determine where the base of the rail will fall. Measure the distance between the rail base and the end of the tie. Make a little tie marking jig like this to mark every 5th or 6th tie with a sharp pencil. This isn't crucial, all it is a layout line, so don't worry about extreme accuracy. Bend the rail to the chosen radius, like this, and spike one end in place. Then spike every 5th or 6th tie at the pencil marks until you reach the end. Now comes the interesting part. Get down and sight down the rail. Odds are you will spot small kinks and small curves hidden in the middle of your larger chosen radius. Using the small screwdriver and hammer, tap the rail in or out at the spike points to get a smooth curve. Gently, you're not jackhammering a concrete slab, you know. When your eye is satisfied, then spike some more and check visually again. Now you can gauge the other rail off the one you just laid. Once you have the knack of this, you'll find that you can lay beautiful curves very quickly. Just remember to sight down the track after each delicate adjustment.
You've done some spiking, but you haven't said how many to use.
Alan, I would suggest 4 spikes in every 4th tie as a minimum. If you're using the Katie spiker, then put 4 spikes in every tie. This gives tremendous holding power and resistance to movement caused by temperature changes. Hand spiking is slower and really doesn't give you any better holding power than the Katie spiker. If you want to do it, get pliers that fit your hands. Don't use many pliers unless you have many hands. The secret to hand spiking is controlling and directing the force necessary to drive a spike without moving or deforming the rail. It's also nice if you don't skin your knuckles constantly. Put the spike in the pliers, place the spike so the point is on the wood tie or the hole in the plastic tie. You want to be near the base of the rail but not exactly on it. Push straight down until the nose of the pliers touches the base of the rail lightly. Lightly, remember. Let go of the spike and close the pliers. Use the nose to push the spike into the tie. Don't push too hard or the rail will be deformed. Once you have the knack, you can move fairly fast, even though it will always be somewhat tedious. But don't be tempted to use fewer spikes. You'll be sorry later. Remember, you want your tie colors to vary or you could have track that looks like this. Don't try to work with rail sections longer than 6 feet or you'll be sorry. Driving spikes is a balancing act between controlling the force and directing the force. That's how I lay rail. There are other methods, of course, but remember they all have their traps for the unwary. Experience will come with practice. Speaking of traps, let's look at turnouts. They're the big bugaboo for beginners and veterans alike. First, let me tell you about commercial turnouts. They come in a bewildering array of scales, gauges, and types. Here are some examples. One of the most popular is the plastic tie turnout with insulated metal frog. Usually this has selective power routing. Another type has a plastic frog. This frog is electrically dead and may cause locomotives with short wheelbases to stall. Another common type has an all-metal frog. These are available either built up or as kits. They must be gapped to work properly. The higher the frog number, the smaller the frog angle. The frog number is the ratio of the length of the frog to its diverging route. For example, 4 units of length to 1 unit of spread is a number 4 frog. You must determine frog numbers when you plan the track. The NMRA data book and John Armstrong's track planning books cover the subject completely, so we'll assume you have your frog numbers selected. Now let's look at a few tips for laying commercial turnouts and improving the factory level of performance.
Can turnouts cause serious derailment problems?
They sure can, Alan. Therefore, don't try to force a turnout to assume an angle or curve it wasn't made to fit. You're just building in more headaches if you do. Let's look first at the way to lay turnouts. Make sure the turnout lines up with your track. It's best to plan your work so that the existing track connects to the point end of the turnout. This isn't crucial, and there will be times when it's absolutely impossible to do. Just do so when you can. Once you've made certain the rail ends line up, mark the roadbed where the throw bar slides. This area may have to be recessed. The throw bar must, absolutely must, slide smoothly. Spike lightly and solder this in. Before the final spiking, make certain the rail flows smoothly from the existing track through the turnout. Get down and sight along the track. If all is well, spike the turnout down completely, not too tightly. You want the turnout to sort of, float a bit. If you're not careful, the turnout will sag or dip or even change gauge. To make sure everything conforms to standards, you need an NMRA gauge. Run the gauge through the entire turnout. If anything is too tight, file it open. This is called the check gauge clearance here. It's very important to make sure it's right. If the guardrails are too far from the stock rails, ACC some strip styrene to shim them out. If the guardrails are too close for the gauge to fit, either file out some of the material in the frog or heat the guardrail with a soldering iron and move it towards the frog. Make sure the paths through the frog line up. That means that the closure rails and wing rails have to be aligned for both routes. Don't dull the point of the frog right here, because that may allow a wheel to drop in. Check the top of the whole frog to make sure it's smooth. Any bumps couldn't be in a worse place. The frog flangeways must be deep enough for your equipment. Older wheel sets often had deeper flanges than the current standards. You should feather the points with a file like so. The points have to be sharp so the wheel flanges won't pick them. Break the top edge with a file like this. In HO scale and larger, you can notch the stock rails a bit so the point fits tighter. It's also important to check the alignment of the closure rails and the point rails at this hinge. Any misalignment will almost surely cause a derailment. Use needle nose pliers to straighten things up. A frequent problem is that one of the point rails is too straight. The diverging side of the turnout must be engaged from the points to the hinge. You can bend this rail a little so it forms a slight curve if necessary and thus is engaged for its entire length. Now make sure that nothing projects above rail height to snag couplers. If the guard rails and wing rails have a sharp point, file it off. You should now have a reliable turnout that will require very little maintenance.
Okay, Laurel, we've waited long enough. Let's see you hand lay a turnout.
All right, I'm ready. This is the most challenging and fun part of laying track. But first, I'm going to show you some kit turnouts. You can buy these from several manufacturers. Some are ready to lay, and others must be assembled. Since you lay them just like scratch-built turnouts, I'll show you how to lay a scratch-built turnout. But first, you've got to scratch-build it, and I do that in sub-assemblies. The frog, the stock rails, and the points. My method is based on 30 years of experience and some mistakes along the way.
How do you know what to build and where to put the sub-assemblies?
You need templates like this. You can buy them from the NMRA or your hobby shop. Obviously, you first have to lay the ties. Make a jig for your turnout size. There are several schools of thought on tie placement, even among the real railroads. I would suggest you not worry too much about it. Just follow your template or work out a sensible arrangement, something like this. Laying turnouts is really just like laying plain track, plus a few more steps. Here are the tools you'll need: the rail, an assortment of files, a motor tool with a grinder, rail nippers, turnout templates, a flat pine board, 40 to 50 watt soldering iron and solder, spikes, needle nose pliers, hemostats, small pieces of phosphor bronze sheet metal, a hand vise, regular pliers, and tin snips. I recommend that experts lay turnouts in place on the layout. If you're not an expert, I'd suggest you build your first several on a separate board that has a template attached. First, we'll build the frog. Wear eye protection anytime you're grinding. Make the point of the frog from two pieces of rail like this so they butt together smoothly. Leave plenty of rail projecting out. It's easy to cut off later. Instead of grinding, you could file the point, but it would take longer. In fact, if you have a bench grinder, the whole process can go a lot quicker. Spike these two pieces onto the template. Form the wings of the frog by bending some rail to match the template. Spike the wing rails only in the frog area. Let the tails or the closure part of the rail stay loose. Solder the whole frog subassembly together. You'll scorch the template in the process. Make sure the solder joints are good. Now bend the closure rails to follow the template. And nip the rails off very carefully where the hinge will be. Spike these rails down securely, and the first subassembly is completed. Determine where the points and the stock rails will touch, and grind off the inside base of the stock rails everywhere they touch. Lay them on the template and spike, except in this area where the points touch. Bend the guardrails to match the template. Solder the guardrails, base of the guardrail to to the base of the stock rail. Check the guardrail clearances with your NMRA gauge, since you can't always rely on the rail bases giving you the perfect clearance. You may have to file the rail bases a little bit, or you may have to add a strip of metal.
So far it doesn't look too hard. Maybe I could help with the last subassembly.
Sure, but this part is a little ticklish. You must file or grind 2 lengths of rail to match the template. They must be very smooth and evenly tapered. A good way to do this is to cut the 2 pieces of rail longer than necessary and solder them at the bases. Now with one end in a vise, file or grind away from your chest, slowly and carefully. Taper the rails to match the template. Separate the 2 pieces with a hot soldering iron and clean off the solder. Cut off the end of the excess rail and spike the rail to the template. Now we need some kind of hinge. Rail joiners are popular, but they can cause electrical problems later. The best bet is a small piece of phosphor bronze strip cut and soldered to the outside web of each point closure rail. This gives you a hinge of great strength and electrical conductivity. The throw bar is installed on this turnout. It can be made of brass, steel, or plastic. Keep the joint here down as low as possible to avoid falling flanges. Make sure there's enough space for the throw bar to pass under the stock rails or between the stock rails, depending on which type you use. Be sure to allow enough distance between each stock rail and its open point. Too little space will cause metal wheels to short out. The turnout is now complete, ready to be moved to the layout. I've soldered 4 thin strips of 10-plate steel across the top of the turnout so that all components have at least 1 strip holding them. Now I'm removing the temporary spikes. Do this carefully, and then when you're finished, lift the assembly very carefully. Spike it in place carefully on the layout, like this, and so. Unsolder the strips that are holding the turnout in gauge and clean the solder off the tops of the rails. Then perform the same checks with the NMR gauge that I showed you with the commercial turnouts. That wasn't too bad, now was it? Remember, line up the turnout with the existing track so the rail flows smoothly. Use your NMRA gauge to check all parts of the turnout so this doesn't happen to you. Subassemblies make scratch building turnouts much easier. So you have all these turnouts, either commercial, handmade, or a mixture of the two. How do you throw them? If they're all within reach from the layout edge, you might consider a manual throw. Several of the commercial turnouts come with manual throws that work fine, or you can buy a manual throw separately. Don't overlook the old choke or automobile speedometer cable. It runs from the turnout linkage to the front of the layout. You have to anchor both ends of the cable's outer jacket with pipe clamps and put a knob on the end of the inner rod. Mount this on the layout fascia board. Undoubtedly, electrically thrown turnouts are the ultimate in luxury, and in hard-to-reach areas are a real necessity. There are 2 types, the solenoid and the motor. The solenoid or coil type has been around for decades and in many forms. It's inexpensive, it's noisy, it moves the points too fast, and it frequently gets out of alignment. There are new plastic mounting brackets that simplify mounting, thus relieving most of the adjustment headaches. All in all, the solenoid types are excellent for the money, and everyone's used to their shortcomings, so I don't think anyone really notices the noise or the speed. The other type is much newer. This is either a motor operating a jack screw mechanism or a motor operating a lever arm through a gear reduction train. Either method gives a slow motion to the points and multiplies the force of the motor many times its own strength. They are much more expensive than solenoids, but are much easier to install. Once adjusted, they rarely need attention. I have over 100 on my layout, and failures are remarkably rare. They exert tremendous pressure on the stock rails, so you may want to put in a few extra spikes. Take your pick. Both are good ways to take your hand out of the picture when it comes to throwing a turnout. Oh yeah, the last word on this subject. You can buy good linkages at the hobby shop if you don't want to make your own. Ballast and final track weathering go together. They're the finishing touches to well-laid track. First, I'm going to show you the procedure I use to ballast track. It's called the dry ballast method. Dry ballast glue is sold by John's Lab and others. Mix 1 part glue with 5 or 6 parts ballast in a container, then stir thoroughly. Apply it to the track with a small mixing cup and a spoon. Make sure you don't miss any spots and heap it up something like this. Cut a stiff cardboard template to use as a spreader, or buy one. Run it along the track several times until the ballast is roughly shaped and sloped. Then brush the track with a soft, dry brush until most of the glue dust and ballast grains are gone. Now take a spray bottle of water with a drop of detergent in it and start spraying the track. Soak everything completely. Allow it to dry overnight and you'll have very solid ballast. If there are any crumbly spots the next morning that didn't get enough spray, then just spray some more. If you hand lay your track, you have the choice of ballasting before or after you lay rail. As to ballast selection, I suggest you drive out and look at the prototype. Ballast is only clean and uniform in size and color when the railroad has the money to haul in tons of washed, crushed rock from a central quarry. A less affluent line will use what's available. In either case, the rock will rarely be a uniform color, so you want to mix colors. But don't use widely varying colors such as black and white, because you'll get the dreaded salt and pepper effect. Keep the scale size of the rock accurate, about 1 to 2 inches in diameter. You can buy a bewildering array of ballast at the hobby shop or dig your own. Your track is almost finished now. The last thing is the final weathering. This can only be done after everything else. Make up a revolting looking mixture of 10% grimy black, 10% engine black, and 80% dirty thinner. Streak a dark ribbon down the center of the ties to simulate oil drippings from steam and diesel locomotives. At signals or other logical stopping places, put a heavy concentration of oil. The locomotive would drip oil while waiting for the highball. If you use flange oilers as a bit of detail, be sure and guck up the surroundings. Put an intense concentration of glossy black anywhere a locomotive was parked repeatedly. Your engine house or roundhouse should be virtually filthy. This isn't the place to be clean and neat. If your railroad is strictly diesel, there should be very little oil on the tie ends. If you have steamers, remember the valve motion caused an unbelievable amount of lubricant to fall on the tie ends. This built up over the years into a sizable accumulation. On ascending grades in places where locomotives have to start trains, you're going to find sand. Sprinkle some fine white sand mixed with dry glue over the rail. Wet the area, clean off the top of the rail after the sand dries. Now stand back and look at the finished product. Ain't that beautiful?
What help or advice do you have for people with problem track they laid before they saw this tape?
Well, Alan, there's 7 areas I'd like to talk about. Rail joint kinks are the most common track problem. The quickest solution is to pull the spikes and put in small finishing nails. Tap them into the road bed so that the kinked area is held in a smooth curve or line. Now solder the rail joint carefully now and allow it to cool completely. Then you pull the nails and respike thoroughly. It's possible that in some cases the rail is bulging because it's too long. This is best solved by cutting the rail with a cutoff disc or a razor saw. Generally, this will remove just enough material to allow the rail to curve or lie correctly. The second common problem is track that's out of gauge. This plague is visited on those whose layouts aren't in a perfectly controlled environment, and I guess that's all of us. Your best solution is prevention. That's why I've been pestering you about using lots of spikes. If you didn't use enough spikes, then use the small hammer and screwdriver I showed you when we talked about hand-laid track. Tap things back into gauge and use plenty of spikes this time. The third problem area is radii that are too small. If you've done a dude like this, it's too late. A dangerous expedient is often tried. Widening the gauge beyond standards is really asking for trouble. The best idea is to rip it out and start all over. The fourth problem is undulating track, in other words, sags and humps. Fix a sag by shimming it up with sheet styrene. If the sag is severe, use a short piece of styrene, cover it with a longer piece, and then an even longer piece until the sag disappears. If it takes too many pieces, maybe you better start over on that area. A hump can be reduced in 2 ways. If it's very slight and you have plastic ties, you can use a 200-watt soldering iron and rub it back and forth across the hump until the ties soften, not melt. This will reduce the hump. Be careful while you're doing this. If the hump is severe, remove about 2 feet of track and sand down the roadbed. Check constantly to make sure you don't sand too much. Then relay the track. The fifth problem, Alan, is a vertical curve. This occurs where the track changes from level to a grade or vice versa. If the curve is too abrupt, you're guaranteed derailments in binding locomotives. You can think of the vertical curves as either a sag at the beginning of the grade or a hump at the top of the grade when the track levels out. Eliminate vertical curves by treating them just like sags or humps, shim or sand. A sixth problem can be lack of guardrails. Guardrails are attractive and useful devices for the prototype and model alike. Everyone uses them on bridges, but don't overlook such useful places as right before the points of a curved turnout or of a regular turnout that's at the end of a curve. Use guardrails any place you want to guide the wheel so they won't pick, ride up, or slide over the rail. The final problem area, Alan, is really very general. It's the kind of problem and derailment that happens only occasionally and not with every piece of equipment. In this case, check the equipment first. If it's all right, then you probably have a smaller radius hidden inside your curve, or maybe the roadbed isn't level. Both of these require the attention we've discussed. Also, if the rails are misaligned at a joint, some equipment will tolerate it and some won't. Track is not the only cause of derailments. Couplers, trucks, car weights, and car lengths can all play a part. In this tape, I've tried to pass on some of my track work philosophy. I've tried to dispel some of the horror stories you've heard about how tough track laying is. Well, if you approach it with a let's get it done as fast as possible attitude, it can be tough. Why not enjoy just another phase of layout construction? So remember now, 75% of your derailments are going to be at turnouts. Most of the rest will be at kinks, sags, or gauge changes. If you use your NMRA gauge carefully and take your time, I know you can do everything I've showed you here. At my track work clinics, I've seen people do things they never thought were possible. You can kind of look at track work this way, folks. You may never think you've got time to do it right the first time, but you've always got time to do it over. I think that's Murphy's Law 609. Keep them rolling, partner.
For more tips on track laying, be sure to read these useful books: The ABCs of Model Railroading, Popular Model Railroads You Can Build, HO Primer, and N-Scale Primer. And for model railroading fun every month, don't miss the latest issue of Model Railroader magazine. Visit your favorite hobby shop today and ask for Model Railroader, Kalmbach How to Do It books, and Model Railroader video cassettes.